Thank you. Good afternoon, everyone. My name is Sana Suri, and I'm a neuroscientist at the Warnford Hospital. I use different types of brain imaging methods to study risk and resilience for dementia. So today, I'm going to talk about the heart-brain link, and kind of a phrase that Katie touched upon in the morning, which is what's good for the heart is good for the brain. And I think that this cartoon kind of illustrates that quite well. So here you've got a brain that's obviously read every one of those sensationalized headlines that Katie showed us in the morning. It's got a pamphlet that says, everything is poison, and now you're poison too. And the brain says, you know, heart, there's new research into heart disease that says, and the heart stops the brain and says, let me stop you. If you're going to make me choose between you and pizza, it's going to be pizza. I think we've all kind of been there. But the heart in this picture has the right idea. So there is a lot of new research that shows that the same risk factors that increase your risk for developing heart disease, so things like high blood pressure, smoking, obesity, having type 2 diabetes, and cholesterol, also increase your chances of having brain diseases, including memory disorders like Alzheimer's disease and dementia. Now, these risk factors can affect the brain in many different ways. They could affect the health of the blood-brain barrier, and that's really important for making sure that the brain gets rid of all of its toxins and gets in essential nutrients. It could then affect the supply of blood to the brain, how much energy and nutrients are supplied. That could then affect metabolism, the efficiency with which those nutrients are broken down in the brain. And then that could lead to downstream effects on the inflammation response, which we heard about earlier this morning, eventually kind of leading into some of the pathological changes that we see in Alzheimer's disease, like the plaques. Now, studying these risk factors is really important, mainly because they are modifiable. So there are things that we can do in our lifestyle or through medical interventions to manage these risk factors to reduce the chances of developing dementia later on. And again, I should state here, it's really important to note that no one risk factor can guarantee a cause for Alzheimer's, but targeting them all could help prevent nearly a third of dementia cases. And this is really important because in our aging society, we're not only living longer, but we're also seeing rising rates of obesity and hypertension. So targeting these risk factors have become quite a critical part of the health policy surrounding dementia. So last year, Public Health England announced this heart age test, which is being incorporated into NHS health checks for dementia. So this test is kind of being disseminated quite widely now, and studying cardiovascular health could have important real-world implications for dementia policy. So the subject of the study that I'm going to talk about today looks at the effect of all of these risk factors on blood supply to the brain. Why blood supply? Well, the brain is a really hungry organ, and it's a very high-maintenance organ. So it uses up 20% of the body's energy, but it doesn't have a way to store energy on its own. So it relies on that energy coming to it very regularly and continuously through the blood. Now, keeping this balance between demand for energy and the supply of that energy through the blood is really critical for allowing the brain to function. And as we get older, we do see a decrease in the supply of blood to the brain, and that's a really kind of expected part of aging. But in Alzheimer's disease and vascular dementia, that decrease in blood supply is more pronounced. So we see sort of early changes in the brain that involve low blood flow. But we still don't know how, and importantly, when in the lifespan, all of those risk factors that I talked about earlier begin to affect blood supply to the brain. So that was the question of the study today. And the study was conducted in 116 older adults without a clinical diagnosis of dementia, and they were selected from the Whitehall 2 imaging sub-study. Now, you may have heard of this study. It's a longitudinal cohort of volunteers who've been followed up very regularly for 30 years. And this is what we call an epidemiological study. So we're not sort of looking specifically at one disease or specifically at one condition, but we're just observing how a group of people are aging. And here we were looking at people across their midlife. So starting at age 48, my colleagues at UCL collected very comprehensive measurements of their heart health every 5 years for 20 years. And the measurement that we looked at here was called the Framingham Cardiovascular Disease Risk Score. So this is a risk score that combines all of the factors that I mentioned earlier: blood pressure, diabetes, smoking, cholesterol, and whether they were on any medication. And we measured this risk score 5 times. And it tells you your chances of developing heart disease in the next 10 years. 1 year after their last measurement of heart health, volunteers came over to the John Radcliffe Hospital, so here, and they had a brain scan where we measured blood flow to the brain using a technique called arterial spin labeling. And what we were interested in is how and when vascular health starts to affect blood supply to the brain. So the first question was, how does total vascular risk over that 20-year period affect blood supply? So we kind of produced a cumulative score combining vascular health over the 20 years, and we found that people with higher vascular risk over 20 years had lower blood flow to the brain when they were older, in all the parts of the brain that are marked in yellow there. So what you're seeing here are 5 images of the brain viewed from the top. So starting from the one that's closest to me, that's the topmost part of the brain, and then you kind of go down up to about the level of the ear. And I'm showing you that just to show you how widespread this low blood flow effect was in the brain. And of course, we controlled for things that may interfere with this relationship, like age, sex, education, their head size, and so on. Next, we were interested in how much of this total effect is due to midlife risk and how much of it is due to late life cardiovascular health. And what we found here was that almost the entire effect that we saw in the previous slide could be observed from the earliest measurement of cardiovascular health at age 48. And interestingly, this effect reduced as we went into the measurements that were acquired in later years, to the point where vascular risk at the most recent measurement at age 68 was not significantly associated with blood flow to the brain. So it appears that midlife cardiovascular health is really important in maintaining brain health as we get older. So sort of the main takeaways from this study are that vascular health in our 40s, as early as in our 40s, can contribute to low blood flow when we are older, and that this may be driven by midlife rather than later life vascular health. And this may seem a bit counterintuitive, but it's actually supported by large epidemiological studies that have shown that it's midlife rather than late life risk factors like obesity and hypertension that can predict your likelihood of developing Alzheimer's disease and vascular dementia. Now, the takeaway is not that vascular health in older age is not important, because it absolutely is. So managing vascular health throughout the lifespan is important. The takeaway here is that it starts to become important perhaps earlier than we thought. So starting to think about it in younger ages is critical. So what am I doing next? Well, I'll be starting a new study that's funded by the Alzheimer's Society. And over the next 3 years, we're going to be looking at how all of these risk factors, like blood pressure and so on, interact with our genetics to influence not just the quantity of blood that's flowing to the brain, but the quality of blood flow to the brain. So we're going to use Doppler ultrasound scans of the large blood vessels in the neck, which supply blood to the brain, to see how stiff those vessels are getting with these risk factors, and then to see whether that affects the velocity of blood flowing to the brain and the pulsatility with which the blood enters the brain. Then we're going to do this really cool scan, which tricks the brain into thinking that it's exercising while you're lying still inside the MRI scanner. So the reason we're doing this is we want to see not just how the blood goes to the brain when we're lying still and doing nothing, but how well our brain can regulate the supply of blood to the brain when the energy demands change, like when we're exercising or walking up a flight of stairs. And then we want to see what knock-on effects this may have on brain structure, on brain connectivity, and on lesions in the brain that we often observe in vascular dementia. And ultimately, the thing that we're all interested in is what knock-on effects all of these internal changes have on our memory and cognitive performance. So that's what I'll be up to for the next 3 years, and I hope to keep you updated with the progress of the study. But in the meantime, if you have any questions, feel free to drop me an email or catch me on Twitter, and I'm happy to answer all your questions. And I just want to end by thanking all the co-authors on the paper that I just described to you today, and this large body of funding and support that has made all this research possible, especially participants of the Whitehall Imaging Sub-Study. And so with that, thank you very much, and I'm around later for questions if you have any.